Assalamu alaikum. Today we are going to start exercise 3.5s of IGCSE Extended Mathematics recommended by AQA examinations. Our topic will be polygon angles. So polygon is the shape, is the 2D shape basically, which has many sides. So we are going to discuss about the angles of the polygons. In question number 1, it says a pentagon has angles of 116 degrees, 89 degrees, 101 degrees, and 153 degrees. Find the other angle. So in a pentagon, definitely there are 5 angles, and we have to find the remaining angle size. So for that purpose, first we need to find the sum of all angles. So we must know the formula that we use for the sum of interior angles in polygon, and it should be equals to n minus 2 times 180. Here n represents the number of sides. So for the sum of angles in the pentagon, we know that there are 5 sides. So 5 minus 2 times 180, and that will be 540 degrees. So now we have 4 angles. So to find the remaining angle size, we will subtract the sum of all these angles from 540. So 540 minus 116 minus 89 minus 101 and minus 153. And that will be 81 degrees. Now let's move to next question. In question number 2, it says 2 angles in octagon are right angles, and the other angles are equal. So we have to find the size of remaining angles. So in octagon, first we need to find the sum of all angles, and that should be sum of angles will be equal to n minus 2 times 180. Here we are actually talking about the sum of interior angles. There are 8 sides, so 8 minus 2 times 180, and that should be 6 times 180, and that will be 1080. So the sum of all angles in octagon should be 1080 degrees. As we know that the two angles are already given, means their sizes should be 90 degrees. So in total, the sum of 2 angles is 180. So first we need to find the sum of all remaining angles. So the sum of remaining angles should be 1080, take away 180 degrees, and that will be 900 degrees. So there are 6 remaining angles because already we have subtracted the size of 2 angles. So remaining 6 angles have equal sizes. So let's divide 900 by 6 to get the size of one angle. So the size of each angle will be equal to 900 divided by 6, and that will be 150 degrees. Now let's proceed to next question. In question number 3, it says show that x and y are equal. So first, in both shapes, we need to figure out that what is the sum of all the angles. So this shape means shape 1 has 5 sides. So here the sum of all angles should be, sum of all interior angles should be equals to 540 degrees because it's like a irregular pentagon. And through the formula, we can also write an equation that sum of angles means 2x because x is unknown, and 3x, so the sum of 2x and 3x and 110 and 95 degrees and 90 degrees should be equals to 540. So let's do the calculation. The variables, so the sum of these variables will be 5x and the sum of constants will be 295. So we'll subtract 295 on the other side. So 5x equals 540 minus 295, that will be 245. And if we divide both sides by 5, we get the size of x as 49 degrees. Now we need to do working for this second shape. Let me count the number of sides: 1, 2, 3, 4, 5, 6. So it's a hexagon. Means first we need to figure out what will be the sum of all angles. So all interior angles should be added up to 720 degrees. So we can also write the equation that the sum of 2y, 3y, and 121 degrees, and 156 degrees, and y, and 149 degrees should be equals to 720. So by adding the like terms, it will be 6y, and when we add the constants, we get 426. So we can subtract 426 from the other side, and that will be 294. Now we need to divide both sides by 6, and that is 49 degrees. So when we worked out for both angles by using the equation, we got the size 49 degrees in both cases. Let's move to next question. In question number 4, it says copy and extend this table for the regular polygons up to 10 sides. Complete the angle columns. So first we can complete the given table. We have regular polygons, means triangle, 3-sided shape, and the quadrilateral, it's a 4-sided shape, and the pentagon, it's a 5-sided shape. And we have to write the size of the exterior angle and interior angles. So in the regular polygons, all the angles will have the same size. So let's take the triangle over here. Means it's a regular triangle, means this triangle is basically equilateral triangle. So in equilateral triangle, we all know that in the triangle, the sum of angles should be 180 degrees. So we have 3 angles, means each angle size is equal to 60 degrees. Means each interior angle is of 60 degrees. Because we have 3 equal angles, so if we divide 180 by 3, we get 60 degrees. So it's 60 degrees over here. And now we will also talk about the exterior angles. So the sum of all exterior angles in all polygons will be 360. Means in the triangle, if it has 3 exterior angles, so the sum of exterior angles should be 360 degrees, and each exterior angle will be 360 divided by 3 means 120 degrees. So it should be 120 degrees. Now we need to work out for the quadrilateral, and it has 4 sides. So the sum of all angles in the quadrilateral should be 360 degrees. Means sum of interior angles should be 360. So we can divide 360 by 4 to get the size of the interior angle. So in quadrilateral, the sum of interior angles should be 360. All the angles are equal in size because it's a regular quadrilateral. So we can divide 360 by 4 to get the size of each angle. So each interior angle will be 360 by 4, and it will be 90 degrees. So each interior angle will have 90 degrees size. And now to get the size of each exterior angle, the sum of all exterior angles in each polygon will be 360. So we can again divide 360 by 4 to get the size of each exterior angle. So there will be the same working for the quadrilateral because sum of exterior angles will be 360 and each exterior angle will be 360 by 4 means 90 degrees. So here the size of each exterior angle and interior angle will be 90 degrees. So it's a special case. We can also work out for the pentagon. So in pentagon, sum of interior angles equals to 540 degrees. If each angle has same size, so we can write each interior angle will be equals to 540 divided by 5, and that will be 108 degrees. Now to get the size of exterior angle, we know the sum of exterior angles in all polygons should be equals to 360. So for each exterior angle, we can divide 360 by 5, and that will be 72 degrees. So we can complete this table, means the size of each interior angle will be 108 degrees and 72 degrees will be the size of each exterior angle. So I'm leaving the remaining parts for you because it's very easy to complete this table. So please try by your own. In question number 5, it says a dodecagon is a polygon with 12 sides. 11 of the angles of the dodecagon are equal to 154 degrees. And we have to find the size of the other angle. So first we need to find the sum of angles in dodecagon. So sum of angles, interior angles, should be n minus 2 times 180, and there are total 12 sides, so it's 12 minus 2 times 180 means 10 times 180. So sum of all interior angles will be 1800 degrees. As we know that the size of 11 angles is 154, so in total size of 11 angles will be equal to 11 times 154 degrees, and that will be 1694 degrees. So we can easily find the size of remaining angle, that will be 1800 minus 1694 degrees. that is 106. In question number 6, it says a regular polygon has 15 sides, and its A part, use the angle sum of this polygon to work out the size of interior angle. So if it is a 15-sided polygon, then the sum of angles will be equal to, we can use this formula, that is n minus 2 times 180, as there are 15 sides, so 15 minus 2, and it should be 13 times 180, and that will be 2340 degrees. So if we want to work out for the size of one interior angle, then we will divide the sum of all angles by 15. So size of each angle will be equals to 2340 degrees divided by 15, and that will be 156 degrees. Now in B part, it says use the sum of exterior angles to check your answers to part A. Basically, the sum of each interior angle and exterior angle will be 180. So let's work out for each exterior angle. So the size of each exterior angle will be equal to 360 divided by 15, because the sum of all exterior angles should be 360 degrees. And if there are 15 equal angles, so we can divide 360 by 15 to get the size of each exterior angle. So it should be 24 degrees. Now we can use this property that the sum of exterior and interior angles should be equal to 180. So if each exterior angle is 24 degrees and each interior angle is 156 degrees, so let's take the sum of each exterior and interior angle, means 24 plus 156, and that should be equals to 180. So we have got two equal sides, means we have verified our solution of A part. In question number 7, it says describe the symmetry of regular pentagon, regular octagon, and regular decagon. So first of all, we will see the pentagon. Pentagon is a 5-sided shape, and it's a regular pentagon, means all sides are equal in length. So to see the symmetry, first, if we carefully observe that if we rotate the shape by 360 degrees, then we will get the same shape or identical shape by 5 times in its full rotation. So its order of symmetry should be 5, and let's see the lines of symmetry. So this is the first line of symmetry, this is the second line, and third line, and then fourth line and fifth line of symmetry. So there are 5 lines of symmetry, and the order of rotation is 5. So let's write down the lines of symmetry and order of symmetry, or we can say order of rotation. So in regular pentagon, there are 5 lines of symmetry, and similarly, the order is 5. We can also observe octagon and decagon. And similarly, if it has 8 equal sides in octagon, then it will have 8 lines of symmetry, and order of rotation will also be 8. And in decagon, it has 10 equal sides, so its order of symmetry will be 10, and its lines of symmetry will also be 10. Let's proceed to next question. In question number 8, it says find the size of smallest angle of this pentagon. So first of all, we will find the value of x by considering the sum of all angles, sum of all interior angles of this pentagon. This is basically 5-sided shape, so this is pentagon. So sum of interior angles can be found by using this formula, which is n minus 2 times 180. So if it is pentagon, then we can write n as 5 minus 2 times 180, so it should be 3 times 180. So the sum of all interior angles will be equal to 540 degrees. Now we can also make the equation, as we can see all angles in terms of x. So we can also write the sum by taking the sum of all angles, means x plus x minus 15 plus x minus 50 and plus x minus 30 plus x minus 40. So it will be equals to 540. So if I add the variables over here, so I have 5x over here, means we can add all the variables. So I can write 5x. And if I add the constants, so it's negative 15, negative 50, negative 30, and negative 40. So in total, it will be 135. Now let's calculate the value of x, means 5x should be equals to 540 plus 135. And we get 675 on the right side. Now, if we divide both sides by 5, we will get x as 135. It means the size of x is 135. Now to find the smallest angle of this pentagon, definitely it will be the one which has maximum subtraction. Means if we subtract 50 from 135, so we can get the smallest angle. So smallest angle will be equals to x minus 50. So 135 minus 50 degrees will be equals to 85 degrees. So this is the smallest possible angle over here. Let's proceed to the next question. In question number 9, it says the diagram shows a regular nonagon divided into congruent triangles. And in A part, they want us to find the angles marked x and y. So from this above given information, we can observe that the 9-sided regular nonagon is basically divided into 9 isosceles, or we can say congruent triangles. Means this angle at this point, let's consider this point as O, means this angle is divided into 9 equal angles. So from this information, we can easily find the size of x. Means size of x will be 360 degrees divided by 9, and that will be 40 degrees. Now, as it is given that all the triangles are congruent, means their corresponding sides are equal. So if we consider these two corresponding sides of this triangle, then we can also say that the triangles are isosceles, means their base angles will also be equal. Means their base angles will also be equal in size. So this can be also considered as y. So for calculation of y, we can write the sum of the angles in the triangle. We can say the angle y, and the sum of x, angle x, will be the sum of angle x will be equals to 180. To get y, we can simply calculate, because as we already know the size of x, which is 40 degrees, and let's subtract 40 degrees on the other side and divide both sides by 2. So we can easily divide, so we'll get the size of y as 70 degrees. As question number 4 is already done, so please visit question number 4 for more information. Thank you. We are moving towards the next question. In question number 10, we have to calculate the size of angle y. And first of all, we can see that we have equal sided polygon, and there are 6 sides, means it's hexagon. So we are actually dealing with the interior angles. So first of all, we have to figure out that what will be the size of each interior angle. So for the size of each interior angle, we can use this formula, that n minus 2 times 180 divided by n. We already know the number of sides, which are 6. So 6 minus 2 times 180 divided by 6. It should be 4 times 180 divided by 6. And I think that should be 120 degrees. It means the size of each interior angle in the regular hexagon will be 120. We have to figure out the size of y. For this purpose, let's consider this triangle as isosceles triangle. Means the base angles will be equal in size. We can consider the base angles as x. So to calculate x, we can write the equation for the sum of angles of the triangle should be equals to 180. So angle x plus 50 degrees should be equals to 180. To get the size of x, we can write 2 times angle x plus 50 equals 180. For x, we can subtract 50 on the other side and divide both sides by 2. So it should be 130 divided by 2, and that should be 65 degrees. If the size of x is 65 degrees, and we already know that size of each interior angle in the hexagon will be 120, so for y, we can write the equation that the size of y can be 120 minus 65, or the size of x. So it will be 55 degrees. Now let's proceed to the next question. In question number 11, PQRST is the regular pentagon, and diagonals are drawn as shown. Calculate the angle APB. APB is this angle over here, which has P at the center, and it joins the rays A and B. So for this angle, first of all, we can observe that these diagonals are making another pentagon inside the bigger one. So another pentagon will also be regular pentagon. So first of all, we must know the size of each angle in the regular pentagon. So for that purpose, we can write the size of each interior angle can be calculated by using this formula, n minus 2 times 180 divided by n. We know there are 5 sides, so 5 times 5 take away 2 is 3 times 180 divided by, there are total 5 sides. So it should be 108 degrees. So the size of each interior angle in a regular pentagon will be 108 degrees. So to solve for the size of angle APB, we can write that angle EAB is 108 degrees. We can see there is a straight line over here. So if EAB is 108 degrees, then we can easily find the size of angle PAB, which should be 180 minus 108 because there is a straight line over here. And PAB is this angle. I can call it X. So it should be 72 degrees. Now we can see that these triangles are isosceles triangles, means the triangle PAB is an isosceles triangle which has same base angles. Definitely this should also be 72, means its size is also X, means 72. So we can easily calculate the size of APB by writing the equation that sum of all angles in a triangle should be 180. We know the size of X, which is 72 and 72 degrees. We can easily calculate the size of APB. That will be APB equals 180 minus 72 and minus 72. And that will be equals to angle APB equals 36 degrees. Now let's proceed to next question. In question number 12, we have a regular nonagon. The sides AB and DC are extended until they meet at point X. So let's extend AB and CD, and they are joining at some point. We can call this point as X. We have to calculate the angle BXC, means this angle. So for that purpose, if we carefully observe the nonagon, we can see that we have a straight line over here. So we can consider this angle as A. And definitely on the other side, again, we have a straight line and it's a regular nonagon. So we can again consider this angle as A, because these two angles are the base angles of an isosceles triangle BXC. So let's write this information here that we are considering angle A, which is basically equals to angle CBX, and it is also equal to angle BCX. So to find the size of angle A, definitely we will subtract this angle, this interior angle, which is ABC, from 180 degrees. So I will write that angle A should be equals to 180 minus the size of angle ABC. ABC is the interior angle. So let's calculate the size of each interior angle in regular nonagon. So the size of each interior angle will be equals to n minus 2 times 180 divided by n. And we have 9 sides, so 9 minus 2 is 7. That is 7 take away 180 divided by 9, and that will be equals to 140 degrees. Now we can easily calculate the size of A. The size of A is basically 180 minus the size of angle ABC, which is 140 degrees. So it will be just 40 degrees over here. As we have written that the size of angle CBX and BCX is same, means A, which is 40 degrees, we can easily calculate the size of BXC by considering a triangle over here. So in triangle BXC, for the angle BXC, we can subtract the given angles from 180. So 180 degrees minus 40 degrees minus 40 degrees, because each base angle is same in size. So in total, it will be 100 degrees. So the size of BXC is 100 degrees. Let's proceed to the next question. In question number 13, we have a regular octagon and all the vertices are mentioned over here. They want us to calculate the size of angle RWS. RWS is this angle, which is the joining of vertices R and S with W. Means we are looking for this angle. To calculate this angle, first we will do some construction, means we will join all the vertices, means opposite vertices. Means we will join all the opposite vertices. So when we join the vertices over here, we can see the diagonals are meeting at this point, which can be considered as O. The diagonals divide the regular octagon into 8 isosceles triangles or congruent triangles. Means all angles which are actually being made over here at O in each triangle will be equal in size. So if I consider a triangle WOV, in this triangle, the size of angle WOV should be equals to 360 divided by 8, because this complete rotation, this complete angle at O is being divided into 8 congruent triangles. So the size of each angle should be 45 degrees. So I can easily mention that this angle is 45 degrees. And as we know, the side lengths, means WO in this triangle, the side length WO and OV will be equal in side, mean the base angles will also be equal. We can consider the base angles as X and X. So to calculate the size of X, we can consider this triangle and we can write the sum of angles in this triangle will be equals to 180. So we can easily calculate by adding the like terms. 2 times angle x plus 45 degrees equals 180. So for the angle x, I can first subtract 45 from 180 and then divide by 2. And that would be 67.5 degrees. Now let's calculate the required angle, which was RWS. For RWS, we can consider a complementary angle over here. Complementary angle means the sum of angles will be 90 degrees. If we carefully observe that there is a right angle over here. So to calculate the required angle, which is RWS, we can consider a right angle over here, means the sum of x and this required angle should be 90 degrees. So let's calculate the required angle, which is angle RWS. That should be 90 degrees minus x. And x is already found over here, which is 67.5. So 90 minus 67.5 will be equals to 22.5. So the size of angle RWS will be 22.5. You can easily observe that there is a right angle over here because RW is perpendicular to WV, and we have considered the triangle WOV to find the base angles first, and then we got the size of RWS. Now let's proceed to next question. In question number 14, we have a regular hexagon, and it says that show that the angle ACD is the right angle. Here is ACD. ACD is this angle, and we have to show that there is a right angle over here. For that purpose, let's do some construction. So if I join the sides, if I join the vertices B and D, I can see that as it is a regular hexagon, means these two sides will be equal in length, means in triangle BCD, the side length BC is equal to CD. It means this is an isosceles triangle. And in isosceles triangle, the base angles will be equal in size. Means this angle at D will be equal to the angle at B. So we can also write that angle B and D will be equal in size. To calculate the size of angles B and D, in triangle BCD, we know that angle BCD is basically the interior angle of regular hexagon. So the size of each interior angle in regular hexagon will be equal, means the size of angle BCD can be found by using formula n minus 2 times 180 divided by n. Because this is the one interior angle of the regular hexagon, so the size of each interior angle can be found by using this formula, and BCD is the interior angle. So let's take n as 6, so 6 minus 2 is 4, then 180 divided by 6, and that will be 120 degrees. So if we carefully observe that the size of each interior angle will be 120 degrees, means this angle will also be 120, and this angle will also be 120, means BCD. Let's work out for the size of angle B and D. We can consider angle B and D as x. So in this triangle BCD, we can write the equation that the sum of x and angle BCD should be equals to 180. So if I do some working, we will get the size of x as 30 degrees. Now we need to observe another triangle, which is triangle ABC. So in triangle ABC, again, we have same base angles, means angle BCA is equal to 30 degrees, as we have got this as the base angle, means this is 30 degrees over here. Now we can easily prove that angle ACD is 90 degrees, because you know that each interior angle has size 120 degrees. So if I subtract 30 degrees from it, we will get the remaining size. So let's finalize our solution. And now we are going to work out for angle ACD. That should be 120 minus 30 degrees, and that will be 90 degrees. So it is proved that angle ACD is 90 degrees, means it's right angle. In question number 15, it says find the number of sides of regular polygon that has exterior angles of 12 degrees. So we know that sum of exterior angles in any polygon will be equal to 360 degrees. Let's assume that there are total n sides over here. So the sum of exterior angles should be the size of each exterior angle times n. Means if we multiply the number of sides with the size of each exterior angle, we can write the sum of exterior angle in terms of the product of the size of each exterior angle and the number of sides. So that should be equals to 360. To get the size of n, we can divide both sides by 12, and that should be 30. So the number of sides will be 30 over here. Thank you.